We have a special double bonus episode this week. So now you're going to get this great episode, your weekly episode. We have a bonus coming behind this. So it's a super great week for Uptime. We're going to talk about RWE selecting Siemens Gamesa for the Thor wind farm. Now, isn't that the coolest name for a wind farm, Thor? And why does America have some cool offshore wind turbine names? And Rosemary?
And then we're going to talk about Vestas, who are claiming that they're going to stop at 15 megawatts for their offshore wind turbine, whilst at the same time, Mingyang is already pushing out to 18 megawatts.
So in Switzerland, we're going to visit some laser-guided lightning. We've seen this float around LinkedIn quite a bit, where they're firing lasers to get lightning to track down the laser. And Alan will kind of give us a brief overview of why he does or does not think that it's commercially viable for wind turbines. And then jumping into a little bit of a review of GE's finances from the fourth quarter, what we think they mean. And then a Bloomberg article about wind turbines taller than the Statue of Liberty falling over, wanting to understand what that means for the global market.
I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with my good friend from Wind Power Lab, Joel Saxum, and soon-to-be guest host of the Fully Charged live event in Australia, Rosemary Barnes. And this is the Uptime Wind Energy Podcast. Our RWE has chosen Siemens Gamesa 14-236DD offshore wind turbines. God, I love that name. And they're sticking with it, Joel. They have not changed the name of their wind turbines. And I can't figure out if someone hasn't told them. But all right.
That's the king out there.
So yeah. So the RWE has chosen them for the Thor wind farm in the Danish North Sea. And the Thor farm will be Denmark's largest offshore wind farm at roughly 1 gigawatt capacity once it's completed. So those Siemens Gamesa turbines are using their patented integral blades. So it's all one piece, cast as one piece, Rosemary. I don't know if LM ever tried that, but Siemens is doing it. And they're 115 meters in length. Now, back to some earlier Joel points about these service contracts. They did sign a PSA for the 72 turbines, which I'm sure is a pretty good moneymaker for Siemens. Now, the real trick is they're going to have this whole site completed by 2027. That's pretty fast based on what some of the schedules are in America. Do the Danish know how to build wind turbines in the water better than America, I guess? That's what it looks like.
I think the answer to that is yes.
Those
they've done it
fast.
before, right? How many have you got in America now? Just
5.
A couple.
Oh, 7.
Right?
Sorry, 7.
7. Yeah. So easy answer to that one. Yes. Let's move on.
Well, the kicker is, Siemens Gamesa won that patent dispute with GE, and I wonder if this is part of the fallout of that. Is they're starting to win some of these contracts just because they've got GE's hands tied for the moment.
But I mean, it is Scandinavia, so that would be, I don't know, more, I guess, of a Vestas or Siemens type area. I know it was a big deal when GE started making deals in Sweden. That was a super big deal for them to break into that market.
So there's not a lot of service history on the 14 megawatt machines from Siemens Gamesa. That seems to be a big discussion around the world as these machines get bigger, especially when they cross a 10 megawatt size, that they just don't have a lot of history with them. Is that a concern at this point? What do you do to hedge your bets?
I think it definitely has to be a concern, right? So it's just like signing a contract on a car to maintain it when there's no experience of the model in sight, right? So I think when you're talking offshore in the North Sea, these companies have quite a bit of experience out there, right? So I think you can eliminate. So if we're talking hedging bets, you have the knowledge of operating out there. Mm-hmm. That's great. So you've got the SOVs, you've got those kind of things taken, and that's some of the big risk out there is understanding logistics and those kind of things. So that's understood. Now this 14236DD machine there's been one installed onshore for I think almost 2 years now.
Onshore.
In Esbjerg. So you have the piece of it offshore, and then you have the one model that's been running. So understanding, I mean, now granted, small sample size, right? So statistically, that really doesn't mean anything. But you've figured out how to do oil changes. You've figured out how to do these things. We don't know what issues might pop up with the blades. Of course, that's a big one when you get going to 115 meter blades out there. So hedging bets, I don't know. Some of the other things we're looking at, say, competitors to Siemens, Vestas looking at $600 to $1.2 billion in possible slush fund for issues and warranty issues that pop up. So maybe you're getting reinsurance against your own stuff. I'm not sure. To me, it's kind of a scary concept.
Why did the Danish get the best names for the wind farms? Like, how did America miss out on that? You know what I mean?
They're Vikings, man.
Yeah, I mean, naming it Thor is not a bad way to go. How can you lose? That's the coolest name around. Everybody wants to be working on that farm.
I worked a lot with a guy called Thor in Denmark, and I thought it was the coolest. Considered it as a name for my son, but had to rule it out because of pronunciation challenges between Scandinavia and Australia.
Yeah, I struggle with that over there, or used to quite a bit. I met a guy over there named Maunus, but in my American dialect, I called him Magnus.
That's another one that had to get rolled out for the same reason.
Until he finally was, until he finally was like, "Hey, man, that's not my name."
So, do we have to start naming the wind farms in America something cooler, like Batman, Superman, Captain America?
Captain America wind farm would be pretty cool.
It would.
I'm gonna be honest.
I would totally trust you guys to actually do it too, and it would be an acronym.
It would.
Yeah.
Totally would. Well, getting back to offshore wind, the head of Vestas, Henrik Andersen, said in a couple of interviews that Vestas is going to stop at 15 megawatts offshore. That they think the 15 megawatts is a bigger machine they want to deal with. They want to make sure that the quality and the durability are in to those 15 megawatts. And if they continue to make wind turbines that are larger, they're just going more into the unknown. There's a lot more risk, and they just thought, we're done. But at the same time, Vestas clearly knows that they're going to be at risk from all the Chinese manufacturers of just really falling behind. The GEs and the Siemens Gamesa's are not really going to stop. So is this a smart move by Vestas at this point, just to hold at 15 megawatts and just maybe see where the marketplace goes?
I don't know. I don't believe it. They might say that they're going to stop, but what are they?
Yeah,
What are they going to do when the market's demanding more than that? Like, oh, okay, well, we won't sell wind turbines anymore. You know, like they don't get a choice about what people want to buy. If other people are offering a bigger turbine and it works out cheaper on a per project cost, then they can choose to stop at 15 megawatts and choose to not make sales. It doesn't, it doesn't sound like good business practice.
Yeah, the market will run them right out.
Yeah. I mean, as much as there's huge technical risks with going big and, we are seeing more failures, and so Vestas could avoid all that, but, you can only survive so long without sales. So unless their plan is that they let everybody else make these, 20 megawatt sales and it bankrupts every other competitor, and then they can, have every 15 megawatts out of themselves because they're the only company left standing. But I think that's a pretty risky strategy. Can they wait it out? The 5 or 10 years, that would be the minimum that it would take. And
goes against what we talk about.
Yeah, Joel, what's the step between quality of product versus in service life versus cheaper installation? Where's that lie?
I would love to see. I'd love to see Vestas say, you know what, for now, we're stopping at 15 megawatts until we can get a proven next step. Because what we talk about on the program all the time is the issues that we see in the marketplace with innovation cycles being too fast, right? Like this model gets put out and that model gets put out and these blades are falling over and this generator's crashing out. and whatnot, because they're not actually getting enough testing time with all these different things. So if they said, hey, until 2028, we're only doing 15 megawatts, that seems more realistic to me. And I actually I would like that approach to say, yeah, we may work on a bigger one at some point in time, but we're going to get a couple of years of experience with it before we put it out in the market. Like, that's kind of one of the things that we're, as an industry, asking for, so that everybody wants the newest, greatest, best thing until it starts to hit them back in the face.
It might be a good,
right. So this was a topic.
It might be a good marketing strategy if Vestas had this reputation for more reliable equipment than their competitors. But I mean, at least as far as I'm aware, Vestas isn't, standing apart as the higher quality product at the moment. They've got just as many problems as everyone else, don't they? What do you guys think?
If they talked about the V90, then we would be great. That was a great platform. That one just works. But yeah, in general, there's no top tier, right? I guess I take that back. I say that the one thing I have heard in the marketplace is an Enercon turbine is a little bit of a step above some of the others.
Especially from service technicians, always tell me how much they love to work in Enercon turbines. It's like working in a Mercedes or something. Nice.
So I think that saying that that's all they're going to do, it just can't be true, for one. But I don't know, maybe there's some tactic behind it, maybe some strategy behind it.
So if you remember several years ago when Airbus built the A380, which is the double-decker massive, I don't know, it's a whole 400 people, 600 people, some crazy numbers, right? They kind of got goaded into that by Boeing. That Boeing faked out, the word on the street is that Boeing threw out some ideas about some 747 that was where the hump had been stretched, and so they had this like double-decker, full double-decker 747 that was being bantied around, and they felt like all the hubbub and the discussion and all the nuances that Boeing was going to do this made Airbus jump into the 380, and then Boeing didn't make that airplane. They made the 787 instead, which is a much smaller airplane. So there is a little bit of corporate espionage, I'd call it, or trickery that is played at a very high level, and you wonder if this is something that Vestas is talking about. It's like, hey, we're going to stop here, but in the back rooms, back here in the corner, I have a bunch of engineers working on a 25 megawatt machine. Okay.
Yeah.
Right. And maybe that's what's happening. It wouldn't be the first time. There's big stakes. Yeah. This is high stakes poker right now. And you see some of the bigger players playing it at the highest level possible. Us on the sidelines don't know all the inner details, but Rosemary's probably right. They probably can't stop here.
No.
But we'll see how everybody else reacts to that.
I've got one more question for you guys on this one. So the last bullet point here in our notes, we're talking about Chinese manufacturers and possibly SGRE or GE building larger ones. At what level, if a Chinese manufacturer, say Mingyang has the 18 megawatt machine out now, if they come out and say, we've got one at 18 megawatts, what cost does that one have to be less than a European-built turbine for someone to actually pull the trigger on installing those in Western waters?
Well, I mean, I don't know. That turbine doesn't exist yet, and it definitely, I mean, even the company doesn't have a really long track record of reliable operation in, in Europe or North America at least. And so I think that they would be competing on things other than just price there. But I mean, at some point it is going to come down to that. But I think at the moment there's such a rush to install wind turbines, such a backlog of orders and supply chain problems and everything, that I think that everything that gets made is going to sell at the moment. So I think it's probably a good time to be taking a strategy, a risky strategy like that, because I think, I don't think that the turbines are just going to sit around over the next 10 years. I mean, everybody's got 2030, intermediate targets on the way to net zero, and they're going to need every wind turbine that can possibly be made up until then. So I think you'd have to really come up with a shocker to have a turbine not sell at all if you could make it and supply it at a
Right.
reasonably competitive cost.
One of the things we looked at a couple of months ago was that some of the Chinese turbines coming in at about 30% of the cost of the European built ones, and that's still kind of quite wasn't enough to move the dial yet. But I think the time will come.
30% less than the European.
70% less. 30% of the
What?
cost. Yeah, it was like 300,000 a megawatt versus $1 million a megawatt.
Wow, I hadn't seen those numbers, and that's not enough. The perception of difference in quality is so great that they would rather have one European turbine than 3 Chinese ones.
Yeah.
Yeah. Okay.
That seems to be the way they're going.
Do you happen to know, Joel, since you're the expert on this topic, according to me, do you happen to know, are there quality statistics out there that would back that up, or is that just snobbery, Western snobbery?
I think if Western snobbery, I haven't seen it. Well, like we don't have the experience in it. I know from the Wind Power Lab side, I don't know anybody directly involved with maintaining or operating a Chinese turbine personally.
Yeah, no, me neither. But I mean, I do have experience with a lot of stuff that's been made in Chinese factories, and I know that there's no difference in quality out of the European-owned Chinese factories or American-owned Chinese factories. So it's mind-blowing to me that there could be such a difference. I sell a product for triple the price because of reputation if there wasn't hard data behind it. That's very surprising to me.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
Well, if you've watched any of Buck Rogers comic or seen any Buck Rogers comics or watched any James Bond movies, right, you see that lasers can do miraculous things. Well, up in Switzerland, they've been using lasers to trigger lightning strikes. Now, that doesn't seem obvious on its face, like how do lasers trigger lightning strikes? Well, these lasers are terawatt lasers, so they're really powerful lasers, and they're pulsating really, really fast enough that they ionize the air. They actually break down the air, superheat the air to where it becomes conductive. So they're knocking electrons off of air molecules, and everything becomes happy and somewhat conductive. And so the little trick here is up in Switzerland, there's a Santis mountain. I'm going to butcher the name. Santis is the way I pronounce it, but there's a Swiss mountain called Santis, which has been a research facility for lightning forever. And they have all the instrumentation, all the cool stuff up there. They also have a tower that's instrumented, so they can record all the lightning parameters around a particular strike. So what they did is they took this terawatt power laser, they put it next to this lightning tower, and they fire this laser up in the air. Now, mind you, they closed down the airspace so they didn't shoot down an airplane or anything. So they closed the airspace off, shot this laser up there when there was a thunderstorm around, and triggered lightning 4 separate times. Now, that's interesting because it hasn't really been done before outside in the real world. They've used lasers inside the laboratory for 20 plus years to trigger electrical breakdowns. But out in the real world, there haven't been any known triggered strikes. So they could actually trigger a strike. And then, as soon as that happened, and there's an article published in Nature, I think it was in Nature, the internet exploded about it. So everywhere it's like, hey, they got this cool new thing. Maybe we can use it on a wind turbine. Rosemary, all the lightning protection on a wind turbine could come off, or we could use it on a building or something to trigger lightning, or around rocket launch facilities like Cape Canaveral.
Yeah, sure. It sounds much simpler than just running a cable down the blade, doesn't it? You just have a terawatt scale laser pointing next to every turbine. That sounds cheap and reliable,
right? And power.
Well, that's the trick.
Power
right?
efficient, right? If you're making you're only making megawatts of power, and then you got to shoot terawatt lasers. There's a zero sum game here somewhere.
Yeah, it's a little tricky. I mean, the technology is interesting, and it may have some applications because we can use it to see inside of clouds. Basically, we can learn more about what electrical activity is happening in the cloud by triggering lightning strikes. We already have a way to do that right now, which is rocket trigger lightning, which those experiments have been happening down in Florida longer than that, probably 40 years, and other places around the world. So what you do, instead of firing a laser up, you just take a little Estes rocket and you put a spool of wire behind it and you just shoot it up into the sky when there's a thunderstorm, and blammo, there's a lightning strike. So there are cheaper ways to trigger lightning. I guess the question is the industry, is the wind industry looking at alternatives? Is that something that they would even blink at? I think that the industry is so in the mode of where they're at, which is what Rosemary's talking about, putting a cable inside the wind turbine blade, that they would not consider any other technology because of the cost. Going back to Joel's point, just because of the cost.
Yeah, if the cost saving potential isn't there, then you wouldn't bother pursuing it. All of these ideas sound like the kind of idea that we would talk about in the canteen at wind energy company. But would you progress it? I mean, I think it's pretty telling if you're literally saying a cheaper option would be to fire rockets into the sky. And I think that might be an indication that your technology is too expensive. So I think probably not. These things the work is cool. I mean, for the reasons that you say, like it's great to learn more about lightning, and that's definitely needed for wind turbine blade lightning protection design. We need to understand lightning better so that we are more confident about how a lightning protection system is going to behave in the field, before it gets out there, because it's such a problem. I mean, we were talking before about how fast technology is moving, and you've got one prototype turbine that's been operating for a year or two, and that's not enough. Well, you just consider how many times that turbine's been struck by lightning, and it's in its experience, it may well have been struck once or twice in its test year, but certainly that's not enough to make sure it's going to withstand every single type of lightning that you're going to experience around the world, to know what it's going to behave like when, materials aren't brand new anymore, because obviously, there's a difference in how materials conduct or insulate when they're brand new versus when they've got, little micro damage through them, like a wind turbine gets after it's been, flexing around a few thousand times.
Right.
Mm.
Well, I look at it this way, because there's similar experiments going on with airplanes at the moment. I won't name the research institute that's looking at this, but there's been some recent articles about instrumenting aircraft so that they're not struck by lightning, or maybe struck by lightning less. It's interesting from a researcher standpoint, but if I'm making an airplane or am I making a wind turbine, what am I going to do different? Probably nothing, because if the system doesn't work, or that 1 out of 1,000 lightning strikes hits my wind turbine or my airplane, it's still going to be bad. I'm still going to put all the lightning protection back into the product anyway. So this cool lightning triggering device on airplanes and wind turbines is just dead weight in a sense. It doesn't change the way you would design a product. And I think that's where everybody gets stuck at. Like, okay, I implement this really cool laser idea. Do I take all the lightning protection out of the wind turbine blades? Probably not, because it only takes one lightning strike, then I'm down. I've just destroyed a turbine. It's not worth it. I think that's the real trade-off at the end of the day, is that you're still stuck with the technology you have, and because it works, at least decently well.
Yeah, right now it's a research experiment, right? And it's cool. Something different may come out of it along the lines, right? Like we've talked about many times here, is that we need to have people doing this smart kind of research to spur on innovation in other sectors. And it's the same way that technology from an F1 race team makes it into your car eventually. But for right now, it's just kind of like a non-start. Like you could go more practical if you want to get something instead of this, put a 500-meter tower in the middle of the wind farm that's just 100 meters taller than the rest of them.
Yeah. Yeah, even that is spotty. That's what
Right.
they
Yeah. I
found
mean,
out,
it's
that
just
even when they try it, it's spotty. Yeah. Does that make sense? I think that's the logic I use with it is, would I change what I'm doing right now? I think the answer is generally no. But I could be convinced. And the other little bit to this, I think, is just their. Um, I'll go to the Rosemary point. Until you actually work in industry, understand all the little nuances to why a design is the way that it is. As a researcher, you're not really plugged into that too much. So it looks like, look, I could do this really cool thing and maybe make an impact in this renewable energy field, which would be great. That'd be fantastic. But they're not really plugged into the lunchroom situation like
right.
Rosemary is, where they're all sitting around talking about why they design everything the way that they do it. And if the researchers were in that mode, were in that space, and were learning those things, I'm not sure they'd be doing some of these experiments. That's my thought, because there's so many things that we could be doing in the lightning space at the moment that we're not doing, just because there's a disconnect between the on the ground in the factory engineers and the researchers in the universities and laboratories across the world. So GE Renewables had a big meeting. Well, GE in total had their quarterly results published, and they broke out renewable energy. So you can see some of the details inside the renewables wind turbine business for GE. And 2022 would be a year to probably forget, because it lost a little over $2 billion in that portion of the business. And everything was down. I was going through all the numbers here. If you look at 2022, they sold a little over 2,100 turbines, and they had 2,200 turbines ordered. Those are decent numbers, but in perspective, that was down over 25% versus 2021 in orders and sales for new turbines. It was just down a lot. But repowering, weirdly enough, was fairly were stable somewhat in terms of sales. Orders were down for repower by about 50%, which is odd, because you think GE would be really into the repowering business, right? I mean, that's got to be a sweet spot for them.
Yeah.
So we got the clock is ticking, right? And 2024 is coming pretty quick. I don't know what the plan is here. If you look at the GE Power business, which is the non-renewable portion of GE Vernova, it seems to be doing okay. It's making a little bit of money. They obviously have a footprint in the marketplace. They are well known. They think they're going to be in like single-digit growth for 2023 in that business. But the renewable side is not looking so hot. Is this just a temporary dip in where GE is going long term?
I hope so. To be honest with you, I really hope so. It's odd to me to see some of these numbers after the IRA bill had come out, especially the repower ones. Because there's probably a lot of people that are sitting there like, we're running, and then I know. But I also do know this from industry knowledge: GE doing repowers can be kind of a pain to deal with. I've heard it from a couple of different people where GE basically says, this is how we're going to do your project. And if you don't like that, then we're out. Like they say, this is how we're doing blades. This is how we're doing generators. This is what we're doing for bearings. We're going to run the whole thing. It's going to cost, bam. And if you don't like that, then there's no leeway. To me, that's a tough way to do business. But
what's driving that, though? What's the reasoning behind it?
I'm not 100% sure. I think part of it is a controls thing. I've also heard people in the marketplace saying, we have GE controls in our turbines, but they have stuff locked out, like we can't even get access to them. So it's almost like they want to keep, like they want to keep it's like the, Ford making special tools that only the Ford technicians can buy to fix your cars, kind of thing, or John Deere tractors, and only the John Deere technician can plug into it with his computer. So if you're 10,000 acres away, you got to wait for him to get out there to fix it. So it could be some of that driving it. So that's a strategy standpoint, right? Technology driven by strategy. But 25%, we know that the wind industry can be kind of cyclical. There's a lot of growth in it, of course, right? But you see numbers up and down, up and down. You don't see, no matter if it's Vestas, Siemens Gamesa, there's never this like nice steady curves, whether they're growth curves or flat, or they're up, down, up, down, up, down all the time, depending on the geopolitical climate in certain parts of the world and what's happening with offshore wind and onshore wind. Big bills getting passed over here, like the IRA bill, or in other places. I know there's talk of opening up the southern part of the UK back to onshore wind, which has had a moratorium on it for a while. That'll drive some sales if it happens, right? So there's all these up, down, left, rights. But so if I'm valuing a company or looking to invest in it and I see 25% drop, that's a tough one to stomach sometimes.
Oh yeah, the numbers got to be a little scary. I'm sure they saw them coming in about June, July, or August of last year. Like, ooh, the second half of this year is not going to be so hot. But they have at least a little bit of breathing space. The scary part about this, from my perspective, is when they start singling out a particular part of a particular business, the financial numbers from the remainder of the business, it always gives you that little sinking feeling like, ooh, there's this little piece over here that's causing us all this pain. Maybe we can get rid of this piece and sell it off, and then all the remainder will be nice, happy profit margin time. That's disturbing to me, as GE's the last remaining U.S. Wind turbine manufacturer. What the heck, right?
How many people lost their positions when they did the cuts back in December or November?
Ooh, yeah. It was 10%. I wasn't like 10% of the workforce. It was something like that.
Was it like 2,000 people?
Number. Well, yeah, it would have to be roughly.
So
sure.
I mean, if you can equate some of that, I mean, some of those are high order engineers. There's some heavy salaries in there. I mean,
there are, but there's not $2 billion worth.
No, it's two or 300 million, so. Right? Yeah. So there's a little bit.
There's a little bit. It really comes down to sales, and in some part it has to be just sales driven. And are they not competitive in the marketplace at the moment because of pricing, because of reliability? What's driving all that? I think, as we're going to discuss here, there's some concerns about some of the GE turbines that are out there, and maybe it's just a perception more than it is a reality. And that when a GE turbine has a problem, it gets huge, wide notice about it across the world. And right, am I wrong about that? I don't think so.
Look at their fleet in the past, right? GE 15s. A GE 15, depending on what blades on it, was a workhorse. There's tons of them installed. The US is full of those things. So they did really good with those XLEs, SLEs. They did really well with them. Then they went to the 1X, 1.6s, 1.7s, and 8s. But now that they're starting to expand their portfolio to, the Cypress, what are they, 5 megawatts, and some of the other ones, I don't know if the developers are looking to install those, to be honest with you, right? So there's little niches and pockets of, we're in a low wind area, or the wind resource here is different, and some of the better spots have already been picked up for some of these other types of wind turbines, and maybe they don't have one that's in that sweet spot right now. I don't know. That would be a technology limitation rather than a sales limitation, but I'm not 100% sure on that.
Right, and GE historically wants to be number one or number two in their market space, right? That was a mantra way back when I used to work there, and they would, if you were number 3 or 4 in the marketplace, your little division got sold off. And it's that legacy, I think, still kicks around in the upper echelon of GE. I'm sure that it does, because the people that are there at those levels were around when I was around years ago, back in the 90s. You don't forget those things. Those sort of lessons that get imprinted into your brain, that the only place you can make money is if you're the first or second into that marketplace. And that tends to be true. But I think GE still has a really decent name in the marketplace. And not to say decent probably is downgrading it. It's good. They make good products. Yeah. I think a lot of people are very happy with them. It's just surprising to see there's not getting as much traction as I thought that they would, especially since they knew in 2021 that 2022 had to be a better year, and it didn't really move the needle much.
In any of their press releases, do they point to anything themselves of that $2.2 billion loss? Or do they just say, we had this loss?
It's not one thing. right? So it's never one thing that gets you. It's a variety of different factors. The war, the economy, inflation, the supply chain, sales group. Maybe they lost an order that cascaded into several orders. It's hard to say. I think it's really hard to say, and I think they'll tell you that too. Every time I've been in discussions about here, even at WeatherGuard, right? When we start looking at, why are we at where we're at? Well, it's a series of probably 100 different variables that we didn't know about when the year started.
Yeah.
It's just what happens as you have a business.
The one that I'm always watching with these, just sitting in the space that I do in the marketplace, is what are they looking at for warranty claims and ongoing costs that are unallocated. And that's the number that I'm looking to see, right? Because we're always being asked from the insurance industry, and we're like, well, which ones to watch out for? What's the ones that we should be worried about? So that's definitely a metric we look for.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
So if you haven't seen it, there's an article on Bloomberg called "Wind Turbines Taller Than the Statue of Liberty Are Falling Over." That's a nice headline, right? That's very search worthy by Google. So the article kind of goes like this. Hey, a wind turbine collapsed in Oklahoma, and it was a GE turbine that was in service less than a year. Okay. And then another turbine collapsed in Colorado a couple of days later, and they blamed the Colorado failure on a blade defect or a blade flaw. And all of a sudden now there's a rash of wind turbine problems across the US and Europe. Like, no. No, but the article continues. They talked to G-Cube, which was a major insurer and underwriter, obviously, for wind energy. And what G-Cube was saying is that they're seeing failures happen in a shorter time frame on newer turbines, and they're concerned about it. Well, sure, if I'd insured them, I would be concerned about it too. And GE, the CEO, Larry Culp, talked about this a little while ago. It says it takes time on new products to stabilize the production line and quality, and some of these are just birthing issues. I think that's valid. That seems like a reasonable explanation for some of it. Doesn't make anybody happy. But then they go on to list some other ones. So Siemens Gamesa has had problems with the 5X blades, which everybody knows about. And Vestas has had a number of warranty claims from 2019 on. I think some of those have been related to lightning issues from news articles I've seen. So it's not just a GE thing. It's a Siemens Gamesa issue. It's a Vestas issue. So pretty much everybody has this. Wind turbines are a problem, that they're having early defects. Okay. What does this all mean? Joel, I don't think it means anything right now. The insurance industry will always adjust to whatever the marketplace is to manage costs, right, and claims. Isn't this just part of the normal cycle of new product developments and in the insurance industry trying to adjust? And it's not like I have to be careful. I read the article like I should be alarmed, but I don't think I'm alarmed right now.
Yeah, it's the combination of a lot of things, but it's kind of a normal, right? So the heavy appetite, and we'll get start back one. I always like this conversation, say like, who runs the world? And everybody usually says banks. Well, no, it's the insurance companies, because you cannot finance anything unless it's insured. So the insurance companies eventually control the market. When you map it all out, that's where it's controlled from. So there was a heavy appetite. Renewable energy, of course, a great place to it's growing. It hasn't been established yet. Like there's not a lot of times that a multi-billion-dollar industry comes, or trillion-dollar industry comes along, that you can all of a sudden jump into from an insurance standpoint or whatever standpoint, business in general. So the insurance companies had a heavy appetite for getting into it, and are jumping into it full force. So there's a lot of insurance companies in there. G-Cube is not one of them that just kind of is by the seat of their pants, right? They've got a good team of risk engineers, underwriters. They're doing their best to hedge their risks and to understand what they're insuring. But a lot of people are just like, yeah, give me 10% of that wind farm. And they have no business being there. So eventually, yeah, I think that the premiums may correct, but it's also the same thing we talk about here, where these innovation cycles, and these guys are talking about it, right? The Siemens is talking about it, Vestas is talking about it, Larry Culp's talking about it. The market wants the newer, bigger, better stuff all the time, and then that shortens the innovation cycle. So it kind of ties back to what we were talking about at the beginning of the episode with Vestas saying we're stopping at 15 megawatts. In my mind, if they could do that for a while until they made the next jump to whatever it is, and had a proper time for R&D and that innovation cycle in their next model, that's smart. But what's happening here, they're not wrong. And, we do a lot of RCAs. We find manufacturing defects. We find design issues, right? In lightning protection systems. And we're looking at some other turbines right now that have some actual, what looks to be design issues in them. And that's a product of going too fast. So,
that's a really good point, Joel. And because I was going through Power and Energy Solutions magazine from last year, right? So I've got it sitting on my desk, and I thought, okay, so what's the issue here? Is it because the OEMs do not have a decent way of tracking their products out in service? And if I introduce a new wind turbine, say I introduce a new 15 megawatt wind turbine to the world, and I just start selling them, am I involved in the observation of how well they're doing? Am I involved in the inspection? Because there's an article in PES magazine. It's from Tom Sulzer Schmidt, who does drone inspections.
Yep.
So they have this really cool 3DX system where they can tag every defect using and Joel, you know more about it than I do, but they can tag every defect and change and track it as an individual change. So the OEMs could actually, in theory, monitor their own product and catch stuff early. That's what I pick out of it, is that they can actually see where an issue pops up maybe in Nebraska before the rest of the fleet sees it, and then tell everybody like, hey, we need to reinforce this area, or we need to watch for these kind of cracks in this area. Doesn't that make sense? Like if Sulzer Schmidt's doing it,
like from strategy.
Why wouldn't, if I'm GE, why wouldn't I say, hey, guys, cool product. I'm gonna hire you to monitor my new wind turbine. Does that make sense?
Yeah, I think absolutely. So like, I know that Sulzer Schmidt does a ton of inspections for Vestas. On Vestas' point, that is a great strategy from a OEM getting one drone provider to basically cover, and I don't know what Sulzer Schmidt's contract is like, right? But if you had one drone provider to cover all of your FSAs, right? I know like GE in the US uses SkySpecs on a lot of inspections. So if you do that with one provider, with one platform, one system, then all of a sudden you can build models and statistics off of this data. But if you've got 10 different suppliers feeding different things left and right, with different AI systems telling you different categorizations, like none of that doesn't work, right? It has to be standardized across the board. So if you come on to like Vestas, they had to have seen something in Sulzer Schmidt that said, these are the guys we want to use. We like their 3DX platform. We like their drone solution. And we like the way their assessments work, whether it's with their AI or however. And we want to use this as the base for our inspections. Now they have to take that. That's step one, really. They have to take that data and then make actionable insights out of it from a fleet-wide standpoint. So, there's some large manufacturer or large asset owners in the U.S. that do this internally, right? Like NextEra being one of them. They have so many turbines. They're really good at trying to understand what's going on in the fleet, but they have a limited view. Yeah. They may only have, I don't know, 100 of these type of turbines or 400 of these type of turbines. They're not Vestas or GE or Siemens that has, could have control or could have visibility into all of theirs. So, go to the next step, right? So the next step is, if they're doing this internally, that's great, but are they sharing the data with anybody? Are they doing anything to fix the problems or to solve the problems? I don't know.
Yeah, that's a really good question. I hope that they are, and that's the way the aviation industry is set up, actually. And if you think about, if you hop on a new Airbus A321 Neo, which I happen to be on, which is a really nice airplane. What they do with those airplanes is they do all the load tests and all the things to pass certification, and then they put the aircraft in service. But it doesn't mean they don't continue to test the airframe and monitor it. And there's a feedback loop that happens there. So in the wind turbine world, we test like Rosemary used to do. They put blades out in service for a year or so and test them, and then they're out in the world and start selling them. The issue then becomes, what do I continue to do with those blades, or do I continue to monitor it, and do I pass that information down? The way that Boeing and Airbus run into this situation is they continue to test and test and test and test while they're selling their product. And if they find a design flaw, they tell everybody because it's a safety issue. At the size of the wind turbines are becoming now, it's a safety issue.
Yeah.
A 1 megawatt machine, no one really cared too much about, but a 10 megawatt machine, I think everybody starts to care a little bit more. Do the insurance companies? I think you're right. The insurance companies do kind of rule the world here, but are they connected with the drone companies like Soldier Smith to rule the world, saying, "Hey, we know everything that's happening behind the scenes, Vestas, or GE, or Siemens Gamesa. We know where your problems are. Either pay us, or the operators are going to pay us, or somebody is. If they have the best set of data, and I can't believe the insurance companies aren't somehow getting isolated data, like clean data."
The gap is that they don't know. They need to be. This is something that we fight in the industry a lot. Not fight. It's something that we're trying to help along, right? So we work on the claim side a lot. That's pretty cut and dry. But that cyclical bit of data from the claim side, and then taking that claims information and getting back with the underwriters and getting back with the brokers, and then after that, and the risk engineers, and then after that, involving the insured to say, hey, this is what we're seeing from the claims process. This is what's going to be in your renewal next year as far as the things you need to do. Let's get together and make sure this is proper, so that you're protecting everybody. Because what you're doing is you're going to keep uptime for the asset owner. You're going to lower the premiums by not having as many failures. So the insurance company will make a little bit more money, the asset owner make a little bit more money, and the industry as a whole can celebrate lower cost of energy and less failures. And that's the way we look at it. But there's a gap there. It's tough to tie that circle together. Because at the end of the day, some of it's driven by profits and whatnot as well. So you really have to run into the right risk engineers and the right underwriters to say, let's share the data here. Let's go through things, because they're concerned about doing their job, right? They're like, I've got to get this policy written out, and they don't necessarily know that, on this turbine from this manufacturer in this dates, we should be looking at this specific defect in there. And if they haven't inspected it internally, then we shouldn't put them on risk before we know this. Like, that information isn't always there. And that's where, one of the things we're trying to help with.
Yeah. Does that mean there needs to be a regulatory framework to drive the connection between the data and the insurance companies and the OEMs to close that loop, just to force the hand of it? And say, hey, if you have a serial defect, we need to know it, and it becomes a safety issue, and we can fine you for it. Which is a thing that is and I don't like doing this, but I kind of wonder, this is where it always ends up, because the disconnects will have to exist. Once you have lawyers in the middle of it, there are going to be wide chasms between insurance and OEM and operators.
I would just like to see. Is
that the only way to resolve it?
I'd like to see the difficulty is you consistently see new players coming into renewable energy insurance and reinsurance. So they're coming from the classical energy world, they're coming from the property world, they're coming from all over the place. Every other 6 months, you see another couple of names. You're like, what are these guys doing in here? Which is fine. Go and do your thing. But don't expect to not have some heavy losses at chance, because you're not doing proper risk engineering on what's going on. So I think that if you could get the good underwriters, or and I'm not going to say good, but like the ones that hold a lot of the marketplace, and get some of them on board with making sure that the asset owners and the OEMs are held accountable for what they're doing in the field, you might be able to close that loop from a financial standpoint.
So G-Cube is really set up for this, right? I mean, they're one of them that's clearly in position to do this, and Sulzer Schmitz is one of the drone companies that can be involved in that mix too. That just makes logical sense, but we'll see. I don't think it's going to get resolved this year. Not the way things are going at the moment. We'll put the link to the Power and Energy Solutions article on Sulzer Schmidt in the show notes, so you can see it. You can see what the 3DX system is and get a sense of like how powerful this is to find defects and identify them early. Because I think that's part of the key to getting rid of these turbine collapse issues, as we can detect early. Makes a ton of sense to me. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform. Take a moment and subscribe in the show notes below to the Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy Podcast.